Okay, I'm going to go ahead and get going. Thanks, everyone, for joining me in this workshop. I think it'll be a really fun, very speedy 3 hours for everyone. And so what we're going to be talking about is web components and RxJS. Has anyone used web components at all, or at least know what I'm talking about with that? I know we've used like React, and we have like Reactive Components. Web components is more of just the browser standard. So we're going to be working on that, and then RxJS. Has anybody used or has heard of RxJS before? A little bit. Okay. So this is going to be a lot of new material for everyone, and I imagine a lot of people will be a bit overwhelmed with the amount of things, so feel free to just speak up, ask a question, and we'll just kind of go from there, because I want everyone to make sure that you guys get out of this what you guys want, that you guys learn and understand some good fundamentals. And so, again, if you're coming in late, we're going to be working on a project that is set up here in this repository. So that's all set up there on Slack. And this is currently being recorded. So this will be available at the end of the workshop, and I'll make sure that the recording and any other relevant activity that's on Slack will be shared. So again, the Slack channel will probably be archived here within the next week, so you guys don't have to be part of that. But I'll wrap it up and share it around with everyone. So in terms of what we're doing here, roughly we're going to have this first hour will be lecture. Then we're going to have a little bit of a break, and then we're going to have 2 more hours of actually building. And again, if you need to step out, feel free to step out. We are going to be, the work that we're going to be doing is going to be split up into 7 different exercises. So if you aren't following along, or maybe a certain exercise isn't quite working for you, that's fine. The next exercise picks up where you need to pick up for that exercise. So it's not like if you fail on exercise 1, you can't get to the end. It'll build up. And if you want to work on any of this on your own outside of those workshop, again, it's all available to you. So feel free to go about that. So some goals with this. We're going to be building an app. We're going to be using web components. We're going to learn some RxJS. And we're also going to use some rendering libraries. So I think a lot of people might be familiar with React as one, but lighterhtml is another one that I will be introducing. We aren't going to be bundling source code, so we're not going to be using Webpack or anything like that. We're going to be using some newer capabilities the browser has available, and that will be good enough. And we will not be styling anything, so all the CSS and other assets are already built. So you will only be writing JavaScript. That's the hope anyway. So now demo. What are we going to be doing here? So if we go back to this screen, which I believe if you're following along, you should be able to see. You can see the different exercises, and I'll get into that once we get going on the exercises. But if we open up the demo, you can see here that we are interested in making an app that rolls some dice. So if I want a D6, this is your standard cube, I can click on this thing. And now I see that I have 1 D6, and it's rolled, and I have a total of 3. I can click on this again, and I'm rolling the dice again. Let's say I want multiple dice, because maybe I'm crazy and I want to play Yahtzee or something. Those end up rolling. I can again, roll individual ones by clicking on them. I can roll them all, and I get the total immediately. Or I could just say, you know what, I want to wipe the board clean, and then they're all gone. So we have lots of different dice that we can use here. And you can see all the totals that kind of go. So we have a D4, a 4-sided dice, D6, your standard cube with 6 sides, a D8, a D10, a D12, and a D20. So this is all that we're starting to build here. Any questions about that? Is that relatively straightforward? Has anybody used anything other than a D6? So we got plenty of examples up here for, again, anyone who wants to use the dice that's not your standard cube. So anyway, that's pretty fun, and I hope this will be a fun ride for you guys too. As a quick aside, I just found like about 2 weeks ago that Wendy's has their own version of this same thing. You can see here, theirs is a little bit different. You know, I can, every time that I click one of these, I get the value right over there. There's a little bit of a history. There's also an ability to modify the current number, because again, in RPGs, sometimes you can modify up or down a few. So anyway, this is not a unique idea by any means, but I think it's still a fun thing to try out. So that's what we're building. So some principles. Let me make this a little bit larger. That might help out here. Is that better for you guys? Okay, so the DOM is the interface. So what that means is we're going to be using attributes, properties, and methods in order to push information around the different components. We're going to be using events that bubble up, and we're going to be using just standard data types. So we're not going to try to do something where we are passing a odd sort of data structure from one component to another. We're trying to make it where every component is kind of as technology agnostic to the other ones as possible. And what that should enable is that if one web component is using a certain technology stack and another one uses a different tech stack, that's perfectly fine. They should be able to communicate with one another. And it's not like you need to use RxJS for everything. Maybe you use RxJS for just one component. That's perfectly fine. It should be able to work. We're also going to try to reduce side effects. And so a lot of this kind of happens when you are mutating data rather than writing immutable, writing it in more of a immutable way. Some of that is like if you write a let variable, that will kind of allow you to modify that elsewhere in the code. That can get pretty messy. We're just going to be using consts, and that'll really allow you to kind of write code in a more scalable way. And this will also mean that we're writing more testable code. So again, with the side effect, that means that we're trying to make it where anything that happens in one place, like all the effects kind of get isolated in a way in which you can replicate it. So with this, we have two different functions. You have the same output for the same inputs. And then lastly, we are, with RxJS, it's short for reactive extensions. And what we're talking about is reactive programming. And so you can have like one component as an example that says, I want to tell these other two things what to do. That's what's called imperative programming. That's not what we're going to be doing. We're going to be doing reactive. And what that means is something like here on the right. It says that module B declares that A is a dependency, and A says that like A is going to be saying, here's some information that I'm sending out, but I don't care who ends up responding to it. I'm just putting it out into the world. And it's up to B and C to just basically know that, hey, that information is out there. I'm going to get it, and I'm going to respond to it. All these things will start to make a lot more sense once we actually start going into the weeds with it. But again, this is just kind of some high-level things that we're going to be following. So our architecture. This is basically the demo that I just showed you. So we have this root component. And if your web components have this convention of you have to have a hyphen in the name someplace. And by web components, again, I mean it's HTML. It's a unique HTML tag. So anyway, we're going to be prefixing all things that we build with dice hyphen, and then more or less the name of the actual component. So dice root. And within dice root, we have 3 different components: dice picker, dice toolbar, dice tray. And within there, we have more components that we're building out. So just as a refresher, if I look at this upper piece here, that's dice picker. Each one of these individual things here is what we're calling dice input. Each one of these dice is called dice die. This area in which they're going to be living is dice tray. This area over here is dice toolbar. Okay, so let's get into what web components are. So there's a few different specs that kind of describes what this is. The first is ES modules. So this is where you say script type equals module. Normally, when you are including a JavaScript file, maybe you say type equals text/JavaScript or something like that, or you just don't put it in there at all. There's a new type called module, and basically all modern browsers have that now. And what that allows you to do is simple imports and exports. So now you have multiple files, and you say what you need, and you share it that way. If you've been using things like Webpack, then you do the same thing, but the end result is a compiled file, and then that's what you put on the browser. With this, it's basically the browser is actually following all of those import statements and grabbing all of those files and linking it for you. So you don't need Webpack to do that. So that's one big piece of the web component spec. Another is custom elements. And this is back to what I was telling you guys about before, like dice-root. We are doing that. So that allows you to say, write something like my component, you put down some content, or you just follow the API for the component, and it renders. So you define it by, you say like window.customelements.define. That is built into the browser. And then you say, what is the name of the component? So that's just a string. And then you pass it a class definition in which you say, my component extends HTML element. HTML element is kind of like, basically like a span. It's that same thing. There's one variant that we'll also be using, which is called a built-in element. And that's where you say, you use this attribute called is, and that goes on top of an existing element type. So this is saying, I want a button, but I want that button to behave in a very particular way. So we're going to be doing that in this workshop. So the signature for this is basically you have another argument called extends, and you just say, what is it going to be extending? And then also you need to make sure that instead of saying extends HTML element, you're saying I'm extending HTML button. So anyway, that's how you create custom elements. Another piece is the shadow DOM. I think this is going to be one of the most important parts of the spec, but we are not going to be going into it because we don't have the time. But essentially, it allows you to do things where, let's say I define this input, or define this thing, where I say div ID thing, and put in the content is cool. And I can use shadow DOM to say the content that is put inside of that div, I want to render it in a very particular way. In this case, the output of this should be shadow realm is cool. And that happens because I'm using here shadow root, and then I'm using a thing called slot. And that basically is the same thing as like React children, where it just knows where to put external content. And you can actually have multiple slots. Yep.
When you said it knows where to put external content, what is it?
The browser. So the browser is what's handling attached shadow. I should not double click. The browser is doing this attached shadow. And once you do that, it kind of creates its own kind of isolated environment that is kind of like isolated from the rest of the DOM. So I like almost, you could kind of think of it like an iframe, but a lot more accessible than that. So again, it's a really cool thing. I think everyone should look into it, but we're not going to be diving into that right now. Another thing that is good to know, because it's just part of what web components are, but we're not going to be really using it, is called HTML templates. And so with this, you have a tag called template. You give it an ID, and then you can basically reuse it throughout the code. Again, we're not going to be using it because we're going to be using our separate rendering libraries to do the same thing. And I'm not convinced that HTML templates are really that useful anyway. I think there's better ways to do it. But anyway, that's a good overview of web components. Any questions about that? Okay. So let's dive a little bit deeper now and start looking at some code. So again, here's an example of defining a web component. So in this case, I say this is called custom component custom elements, and I can give it any class name, and I'm extending HTML element, which again is essentially a span. There's a number of things that are built into this. So you have constructor, and I have some notes in here about how to use it that you can go on in your own time. But there are a few different things: connected callback, disconnected callback. That's really like whenever you throw the element on the screen, connected callback says, hey, I recognize that this is on the screen. I'm going to call this callback. And then disconnected means the element is removed from the DOM. So those are essentially your like on mount and on unmount in React, if you're familiar with that. There's also something where you can say attribute changed callback. Now, if I go in here, this first example here, slide 2.2, that's what we're currently on. That is what this code renders as. So if I open up here, this is what I was just showing you. All I'm doing is saying component custom elements. I'm just throwing it on there, and then it renders it. So if I go in here, I can click on this thing, and I can see component custom elements. So that's what happened there. So throughout this workshop, we're going to be using something that's a little bit simpler than all of that class syntax, because we just don't really need it for what we're doing. So I've created a thing called define, and that's within a folder called libutil.dom.js. And there's going to be a lot of things in that lib folder that we'll end up looking at throughout the next number of hours. And so anyway, this is the same thing that you had seen before with the class definitions, except for it's a little bit simpler. So all this is saying is define, here's a component called this thing, and then I give it a callback, and this happens whenever it's mounted in the DOM. So L is just short for the element that we're talking about. So L.innerhtml is this text. And so again, that version that you're seeing is this second one, slide 2.3, and it just renders the exact same thing. So that's to give you some heads up for how we're going to be writing some things. Now, with this, what we're going to be doing is let's kind of take this idea and make it a little bit more dynamic. We were just rendering some plain text, and let's do something that actually changes the markup over time. So what we're doing here is I'm defining a new custom element, and what I'm going to do is I'm setting a countdown. So what this is going to do is every second I'm going to start at the value of 20, and I'm going to knock one off until it gets down to 0, and then once it's at 0, I'm going to stop the timer, and it's going to stop doing anything more. So if I go back here, if I do a refresh, and if I look here, I open this up, I see countdown-innerhtml, countdown, and you can see that this text is changing. That's what we're doing here. So we have this initial render. This calls this function down here, which is just replacing the contents of the element with innerhtml. That's exactly what we did on the slide prior. And so with this, we're going to say countdown equals count. Count is what we saw up here at the top. And so we do that once. That gets it to get on the screen. But then we are also setting up this timer. So set interval is that timer. And that says that we're going to be calling this callback for every second. And so what this is doing is I'm going to take count, I'm going to subtract 1, and then I'm going to render the component again, which means it's going to replace the inner content of that component and render again. And then if count is 0, I'm going to clear, and that means I'm going to clear the interval and basically stop the timer. So that's all that we're doing there. And then at the end, there's another thing that I put in here that if you return a function to this callback that's within this define that is in our utilities, it basically means that it's your cleanup, your unmount. So since we have a timer, we want to make sure that if you have an element and now that element disappears from the DOM, you want to stop the timer so it's not something that just lingers in memory. So this allows you to say that I want to go ahead and just stop the timer prematurely because it's now removed from the DOM. So it's just a nice way to clean up things. So any questions about what you're seeing here right now? We're going to be continuing to use this for the next several slides to kind of build up. Okay.
What exactly define JS is doing? Like, I know you are using it here, right?
Sorry, what was the question again?
So the define JavaScript.
Yes.
class that you are
Yeah.
using here? Can we look?
Okay. Yeah, we can look at that. So if I go in to here, so what this is saying is define, and then we have some arguments here. And what this is really doing is down here where we say custom elements.define, and then we are defining a class that extends a certain tag type, and then you have your connected callback and disconnected callback. It's basically the same thing that I had shown a few slides prior, but I'm just kind of wrapping that around a simpler API for you guys. And then I also have a little bit of a fallback. So as an example, Safari doesn't have support for the built-in web components where you say like button is something else. And so I basically just set up a fallback. So I'm using another NPM package that I published called WinElements that basically covers the same thing. But anyway, that's kind of what's going on underneath the hood.
And do we need to know this when element that you are using?
No, that's all
Okay.
abstracted in this. So you just say define and use it, and then you're good.
Okay, thank you.
Yep. Any other questions before we continue on? Okay, so again here, countdown-innerhtml. That's what we had just seen here. And now we're going to do another version. Okay, well, here, let's go into this. So template literals. We had just seen here, do you see these tick marks? We say tick, and then we have this $ braces. That's called a template literal. You could do the same thing with straight up strings, where you say, like, here's a string, and then you concatenate them with a plus. And that's essentially what we're doing, but we're doing it in a little bit of a cleaner way. So you have this expression where you use a tick mark rather than a quote mark. And then you say, you know, $ brace, and then that just means I'm going to be slapping in a variable in that point. And then there's a variation. Yep.
I see that the symbol expression is not defined at that point when A is being initialized. Is that okay? Or is this an incomplete example?
Oh, like this example?
Specifically the line that starts const A, the second one. Down just a bit. Const A. Yeah, right there.
Oh, yeah, if you copied and paste this, and if you didn't define expression ahead of time, that, then yeah, it would come up where undefined. So you'd have to actually say, yeah, const expression equals something. So yeah, thank you for clarifying. So yeah, and then there's, in addition to just the tick marks to define a template literal, you have tag, where this allows, you're basically passing that string to another function to do something else. And what we're going to be doing with it is creating markup from this. So let's go into this. So this shows using template literals with React and then lighter HTML. So I'll get into those. So I know a number of folks in here has used React. When you're using React, you are likely defining your markup using JSX. And so that is not something that is, the browser doesn't know what that is. So you have to have a compiler to compile it into something that is JavaScript. Now, there are ways to get around that. And we're going to be using that different way here. So what we're going to be using is template literals to do that. So what we're doing here is we have this, and normally you just pull in React and you pull in React DOM. Those are the primary things you use, and you use render. we're going to be bringing in another thing, and this is HTML. This is a template literal tag. We're pulling in from this other library called HTM. And essentially what that means is we're going to use template literals to generate your React code for you. The same thing that, that your Webpack setup would do. It would, it's doing the same thing, but it's there in the browser. So when I say HTML tick mark with this markup, underneath the hood, it's actually saying I'm going to be creating, you know, react.createElement this thing, and this long, verbose JavaScript object in memory. So I can say this is the what and there's the where, and I'm just throwing that into this render function. So you say render into this element called root, this content string. So this, if you run it, works. But you don't have to have JSX or compile it. Yep.
I'm just curious, I noticed that there's no parent element in your HTML string. Is that correct? In React, you have to have like that surrounded fragment.
Okay, yeah.
Is that just
yeah, okay, yeah, you're probably right where that would probably
you need a parent element.
Maybe something like that.
Sure, thanks.
But yeah. So lighter HTML is, I guess, I think I started with the lighter HTML example, and that one you don't have to.
Got it.
But anyway, with lighter HTML, this is just the syntax for the rendering is a little bit different than what React is. And so essentially you say render, and the element that you are rendering is the first argument, and then you pass it a function, and then the string itself. So that's just the syntax for how you end up writing it. But lighter HTML, some benefits is, again, it's all just using template literals from the beginning. So it's not like it's template literals to virtual DOM. There is no virtual DOM with lighter HTML. It's 6.5 kilobytes, so it's a lot smaller than all of these other things where you have to combine HTML plus React DOM. So it's a lot lighter of a solution. And you will actually have a choice on whether you want to use one or the other throughout this workshop, but I'll be defaulting to using lighter HTML. So we can actually rewrite the example that we had before. And so this is using React with the HTML template literal tag. So I have rewrote it where we have, rather than just pulling out define, we also have HTML and render. And for here, I'm saying libutil dom React. So if you're interested in using React to actually do this, you just use this path. So all I do here is I say render, and that's basically the React DOM's render. And then I say HTML, and then I define it with a string, and then I render it to that element. So if I look at that here, that's this example 2.7. So if I refresh, let's actually see this, because this should be pretty neat, where you'd see here that because this is React, it does a better job of dipping the DOM than if you're just saying like inner HTML. And so that's why the number here is updating, but countdown : is not flashing. That means it's not being replaced. So it's being smart about targeting what has changed in the DOM and what needs to change at any given time. Now, if we go into lighter HTML, this is the same example that I just seen before, except for we have a different path for the lighter HTML versions of HTML and render. And this syntax is a little bit different. So render this element using this render function. And again, if I go into here, let's see, can I make that big? Yeah, there we go, that's better. If I do a refresh, so RxHTML is doing the same thing. It's being smart about what changes happen within the DOM. Any questions about that before I continue on? Okay. So we're going to take this example, and I'm going to use it to try to get to RxJS a little bit. So, yeah, question?
Yeah, how does RxHTML know which part updated and not without a shadow DOM?
So RxHTML has like a diffing algorithm underneath the hood, where when you pass it this function, and it knows where you're trying to render to, it can just calculate that diff and know exactly what little piece has changed. And because you're using template literals, that this expression here is kind of like tagged in a certain way underneath the hood to make it where it knows what part of the string is being changed at any given time. Like, so anyway, there's a lot of really interesting documentation if you go into search like mdn.com, I think, on template literals, that really gets into the nitty-gritty of that.
So instead of making changes to a shadow DOM, then diffing the shadow DOM to the real DOM, it is able to drill into the real DOM and do the diff there, right?
Yeah. And actually, we're not using shadow DOM here at all.
Right.
But yeah, whether shadow DOM or normal DOM, it is the same thing in terms of how it would respond.
I think you meant like the internal DOM tracking that it does.
Yeah. So so like with RxHTML, it's not creating in memory the virtual DOM. It just has a different way of doing it that's less memory intensive. So let's take this example that we've done here and transform it a little bit. And let's try to clean it up. So for those, if you've used React, there's a thing that's come out in the last year called hooks. And what's really cool about hooks is the idea that it allows you to write your code a lot more functional in nature. And it kind of gets you away from writing classes, and it allows you to kind of reuse logic in multiple places. So I'm going to write something, show this example here, that is similar in nature to what hooks is doing, but we're not actually using React hooks. So what I'm doing here is I'm going to, like, rather than where I have this count variable, and then I'm, it's a let that I'm mutating right here, and then I have references to it everywhere. I want this to be a little bit more reactive in nature. So what I'm doing here is I've created a custom function called use-state, and I'm passing it that same 20, which is the initial state of that variable. Now, down below is what this thing is. And what I'm doing is I'm providing a mechanism to be able to get the current value of this state object, to change it, to listen to changes to it, and then to maybe even remove any listeners who are listening for those changes. So what this kind of allows us to do is to say, when this count changes, I'm going to be listening to it. I'm going to say on, and then count is going to be just the current count number is going to be passed to it. So I'm going to basically just say, whenever state changes, or whenever I start listening to it, I'm going to render. So that element that I get from define, and then the count variable that I get from this listener function just gets passed down here to render, and then it's rendering from there. So this is essentially the same thing as if you're wanting to say, add event listener, and you pass it a callback. We're kind of just replicating the same idea. Now, another thing that we're doing here is we're going to set up another listener that says, whenever the count changes, I want to see what it is, and if it's 0, I want to clear. And clearing means I'm going to stop the interval and remove any listeners, so I'm cleaning up things. I can see here that when I say set interval, what I'm going to say is every time that a countdown, for every second, I'm going to take the current state and I'm going to set it to something different. I'm going to say .set, I get the current count, and then I return a new count number, which is count -1. So again, this is the same outcome essentially as what we had written before, but it's written in a way that you kind of have listeners, and you're using consts, you're not mutating things. There's a little bit of a different way of looking at it. So if we go back here, countdown-use-state, refresh, and look at this, this is going to be the exact same thing as countdown-lighterhtml. At least it's looking like the exact same thing, just it's written a little bit differently. Any question about that? Does that make sense why that was done? Maybe not. I'm getting to. Yes.
I was assuming that this was a contrived example, so it wasn't supposed to look a whole lot better than the other one.
Yeah, it's setting up some principles for other things. So so this gets us closer to the idea that I had introduced before, which, if we go back into principles, we talk about this imperative versus reactive. That's what I'm doing when I say .on, or when I say .add event listener. That makes it reactive in nature. So we're setting up those listeners. So you kind of have this publish and subscribe model. That's what we're replicating here. So let's look at this, but replace this with RxJS and see what that looks like. And then I'm going to get into really what is RxJS and go from there. And if that's disturbing, you can go ahead and close the door. Thank you. So with RxJS, this is actually kind of similar to what we had written there before, where before we said use state and we provided a number. Here we're kind of going to be showing you something where this says BehaviorSubject, and I still pass it the 20. So I have this variable called count $, and then that's kind of what I'm referencing down here to do what I'm doing. And I'll get into all those nitty-gritties and here in the upcoming slides. But what I'm doing here is, instead of saying set interval, I'm using a thing called interval. That's pulled from RxJS up here. So we have two different import paths. We have RxJS and then RxJS/operators. Those will be the only two places that you'll be importing from RxJS. So as we step through this logic, what we're saying is I'm setting up an interval, and it's going to be going for a certain duration. So our duration is still the 1,000 milliseconds. So it says every second I'm going to go, and then I'm going to walk through this code. So interval emits a value. So it's going to emit a 0, it's going to wait a full second, and then it's going to emit the value 0. And then it's going to wait a second, and it's going to emit the value 1. Then it's going to wait another second and emit the value 2, etc., until the thing is terminated. So what I'm doing here is this pipe is essentially saying that I'm going to take this value that comes out of interval, and then I'm going to take it and pass it on to the next thing. And that thing with the output of with latest from is going to be passing to map, and the output of map is going to pass on to take while. So it's if you're familiar with piping with like Linux, where you're using like pipe character, that's exactly what this is doing. You're just saying passing one output as the input for the next function, et cetera, et cetera. So in order to actually initiate all of this, you have to subscribe. So we talked about the publish subscribe model. So interval is not going to just start emitting things because you define it here. It has to have at least something that is listening for it. And you set up the listener by saying .subscribe. And here at the end, I'm doing a shorthand that is saying that whatever gets emitted at the end of this is going to be put back on it. So what I'm doing here is I am grabbing every second, I'm going to get the latest value from count, which is right now it's 20. And then the output of with latest from is an array of the first thing that was emitted. In this case, it's that interval that goes from 0 to 1 to 2 to 3. We don't need that. But then the second part of the array is what I put in here, which is count, $, which is this value. So I'm getting the latest value from this behavior subject. So the behavior subject is what is keeping track of that value. So I'm going to be taking that number, which it'll be 20, and then I'm going to say it's 20 minus 1, which means 19. And then take while is another thing that's going to say, I'm going to grab that number. Let's say it's 19 now. I'm going to say, hey, is 19 greater than 0? Yes, it is. So I'm going to continue. If that value gets to 0, then the outcome of this function now means that I'm going to stop subscribing. And so at that point, it's going to terminate interval and just stop the entire thing. So I'll get into more details about how that works on here in a little bit. So anyway, we have that one subscription, and the whole point of that is to decrement this value. Now we have this other subscription, and the whole point of that is to render the component itself. And so this just follows the same things that we've done before. And then here at the end, our return statement is just saying, again, that once we, if the component gets removed from the DOM, I want to go ahead and unsubscribe from these two things. So it's your cleanup. So any questions about that? Okay. So now let's get into more fundamentals here. So functional reactive programming. Again, this is describing what to do, not how to do it. So as an example, you have, here's an array, and I'm going to use a dot filter and then a dot map and then a dot reduce. That is functional programming. And that's built into the browser. You can use that right now. An equivalent to this code is we're using let's. We're going to say, I'm going to loop through this array, and I'm going to use if statements, and then I'm going to mutate and tally up this total in order to get the sum total of all of these values. So this is a non-functional example. This is something that we aren't going to do. We're going to try to stay away from that sort of code. And when we're using RxJS, it is functional in nature, and basically you are writing code that is closer to this in format. So you're replacing this dot operator with something that is a dot pipe with operators that fill in as arguments to dot pipe. So the syntax is different, but it's the same thing. Questions about that? Reactive programming. So that's where, again, it's this publish subscribe model. As an example, if I wanted to, let's say I had 3 different values and I wanted another value to change based on another value changing, maybe you have to do something like this. You want to say, I want to set the value of A, and whenever A updates, I want to update the value of C. Or whenever B updates, I want to update the value of C. So you kind of have to have this thing where things higher up have to know about things that are lower down, rather than the opposite. So with something like RxJS, I can use an operator that says combine latest. I can just say these 2 streams, whenever any one of them gets changed, I want to pipe that through, and I run it through this map operator, and then I do a transformation on it. So again, it's this thing C, which is kind of the same thing down here. C is changing live because the contents of B or C change.
What's the type of $A in there?
So
it's that listener type, right? That event generator.
yeah. So all these things that I'm showing you is what we call an observable.
So C dollar is an observable as well.
Yes. And I will get into that too here very, very shortly. So we're going to be using a library called RxJS. So this has been around for a number of years, and over the last couple of years, it's gone more open source. And so it was originally built by Microsoft, but it's really been picked up by the community. If you've used recent versions of Angular, it uses RxJS underneath the hood. But there's a lot of other libraries that follow these same principles, but RxJS is definitely the most robust solution that's out there. And things that you learn from using RxJS can be translated to other languages. So there's this Rx family, so reactive extensions. So there's versions of this in basically any other language. So I know a lot of people here use Java. You can basically take these same principles and apply it to the back end. But we're not going to be exploring that because, again, that's a different workshop altogether. So here are the main things that we're talking about when we're talking about RxJS. You have a thing called an observable. You have operators, and you have subscriptions. So an observable, that's all those little $signs that I was showing you. And it has 2 main things. You have a dot pipe, which you had seen, and a dot subscribe, which you've seen. So when you say dot pipe, the output is an observable. So you have an observable that creates more observables. When you say dot subscribe, you receive a subscription object. So a subscription, you can, it'll have a few different things. The most common thing is this dot unsubscribe. So you can subscribe and you unsubscribe. A subclass of observables is, I call it subject. And that gives you this ability to say dot next. And basically that says, I'm going to force this thing to emit a value. So, and then you have another variation of that called BehaviorSubject, which we had just seen. And that's where you give it an initial value. And then you can actually live query that value without really needing to use any RxJS operators to do so. So I can just say, dot value or dot get value on that observable, and I can just get it. And then we have operators. Operators are anything that creates an observable or something that you run through this pipe statement. So if we look back at this example that I just wrote before here, so we have all of this. Let's see what this is in relationship to what we just learned on the previous slide. So we can see that there are actually two different observables. One is count $, more specifically, that's a behavior subject. And then we have countdown $, which is down here. Countdown $, is the result of all of that. Then we have 4 different operators, interval, map, take while with latest from, and then we have 2 different subscriptions. So that's kind of an overview of, trying to translate those pieces. Yep.
I'm not clear on why there's like 2 observables. It seems like you got this one number that's going to change.
Mm-hmm.
So why are there 2 observables?
So with this, you have one value that is changing. This other thing that is happening, this is kind of the, this is essentially your reducer, if we're familiar with Redux. So it's, I am listening to, or I'm trying to transform that value.
Okay.
It's how you transform it.
Got it.
Okay. So in terms of looking at different data types here, we have a function is something that has 0 or 1 value. So, you just say return, and either you return nothing, you don't say return, or you return something. And that's synchronous in nature. So that means that you run the function and the browser waits until the function is done. And then then it continues down through the source code. Another thing is an iterator. So an iterator is something like an array. And that's something where an array could be empty, or an array could have multiple values. And that's also synchronous in nature. You have to process through the array before you continue on. A promise. Have anyone used promises before? A little bit. That's something that could have a value that return from it, or could not. But that's asynchronous in nature. You declare the promise, and then you set up essentially a listener, and then it completes or doesn't complete at some point in the future. An observable is kind of like the best of all these worlds, where you can either have 0 values it emits, or can have multiple values. It can be synchronous, and it can be asynchronous in nature. So it kind of covers a lot of bases. It's a really good foundational piece for your source code. And I do know that we are going to be running long here for this first segment, but I can make sure that we get this done here by 2:30 if people are okay with extending this a little bit longer. You saw that $. So what's up with the $, in some of those previous examples? It's basically a community convention for, so when you look at a variable, that you know that it's an observable, just easier to track. If I can just look at code and say, oh, it has a $, and that's at the end, I know that that's an observable. So we'll just be continuing that convention. So operators, there are a lot of them. RxJS, there's about 150 different operators. So there's a lot of things to learn. And this is something that you can, it'll take you a long time to kind of get a sense for when to use what, where. But we're going to be using a subset of them. We're not going to be using all 150. There's definitely ones that you use more than others. But they at least kind of come into like 2 major classes. You have what's called a static operator, and then you have something called the pipeable operator. A pipeable operator is something that only can be used within the context of a .pipe statement. So as an example, we pulled in interval, and that's at this top level import of just RxJS. That's a static operator. You just call that wherever, that creates an observable. But these down here have to be within the context of .pipe. So common operators. Again, there's about 150. So which ones do you really need to know if you are going to get going on this? This would kind of be my go-to list. And so there's a few static operators that are useful and a lot more pipeable operators that you'll end up using. And they all are kind of for different purposes. So some of them might be for filtering down. Some might be for transformation, etc. So we'll get to those as we kind of get to them. Now you can also write your own operators. So if the 150 don't work for you, well, you can just make your own. And so there's a pretty simple syntax for doing this. If you just want to take one existing operator and transform it a little bit, that's a little bit simpler. But if you want to do something where you want to create a new operator that actually derives from more than one operator, then you can set that up as well. As an example, there is no good way. Yeah, you can. Yeah, there's some seats up here if you want to. When you are looking at observables and streams, it might be hard to kind of figure out what is the contents of this thing. You know, it's just kind of like I've created this object and how do I kind of figure out what's there? And so this is an example where we are creating a custom operator to basically echo out the contents of these streams through console log. And we can use that by using an operator, extending an operator called tap. And tap is purely about side effects, which basically means that I am just looking at the contents of a stream, but I'm not modifying anything about it. And so anyway, I have this example, and as an example here down below, I'm creating an interval and I'm subscribing to it. And I'm going to use this new debug operator that we just wrote right here. And that allows me to get this output. So I see that debug, and I just give it this initial string A. And then down here, I give it the string B. And then I have this map operation on it. So what I'm doing is I'm taking the value of 0, I'm echoing it out, and then I'm going to transform it by multiplying it by the number 2. And then I'm going to print that value out. So I can see that this is essentially what I get. It says 0, 0, and then after a second it says 1, 2, and then after another second it says 2, 4. So something like this debug operator will probably be using quite a bit, just so you can kind of really see what's going on as you are building out your code. Go ahead and get going again. Okay, so we were talking about subjects. So observable subjects, what are they? So as an example, what we're doing here is we are creating a new subject for tracking events, and more specifically, key down events on a keyboard. So for this, what we want to do is every time that a key is pressed down, we are wanting to echo that out. So we're just using that debug operator that we talked about before. And then we say .subscribe so that it all gets set up. And so the output of that would be here, console log, up, up, down, down, left, right, etc. Now what we're doing here with this for each statement is actually simulating that key down without actually having a keyboard do it. And so this is just to show you basically what would happen. So what we're doing here, we're saying key down $.next. What we're doing is we're simulating a user pressing a key on the keyboard, and that event would normally get pushed into this subject observable, and then it gets emitted down to this debug operator and then echoed out. So we are simulating it again by just taking this contour code string, splitting it up into an array, and looping through it, and then putting each one of those values through the subject. There are some different ways to be able to accomplish the same thing. You can actually use a from operator in order to take an array and output it. So rather than having to do this for each loop using the arrays for each, I can just say from this thing, and then it just works. Another way to simplify this thing further is rather than saying .subscribe, and I pass it a function, and the whole purpose of the function is to put a new value on that subject, I can just say .subscribe, and then I pass it that subject as the value of it. So there's just several different signatures for the .subscribe that you can use. So again, this is just a simple way of just saying that I want all of these string values to be emitted on this key down subject. So that's just what's going on there. So that gives you an overview of a subject, and now let's look at behavior subject. Again, this is a subclass of subject, so you still have the same abilities to say like .next on it, but this also means that it expects a value up front. So this is saying that rather than I'm tracking an event over time, which could occur or could not occur, behavior subject says, I always have a value. Like for me as a person, I always have an age because I'm alive. So I would start off with a value of 0, and every year that would tick up to 1 and 2, and etc. So with this example, what I'm going to say is I'm going to create a behavior subject for tracking the value of whether this light is on or off. So I'm saying light switch $ equals behavior subject, and then on or off is just a Boolean value. So I'm passing it and saying, and it's going to start off with value of off. The light switch is off. And I can go ahead and write a function that toggles that value by saying light switch.getValue. And again, get value is something that I only have because it's the behavior subject. And I can say if it's on, then I want to make it off. Otherwise, put it on. And then I want to push that new value back on to itself. So what that does is whenever I say toggle toggle, that is going to change the value down here. And this subscription is just listening for that value change and just echoing it out. And that's what you get down here. Now we can change this around a little bit further and say, okay, whether the light is on or off is a value, but the action of toggle, like me actually putting my hand up and doing this thing, is an event. So now I can say, here's this event, and that's going to be transforming that value of whether the light is actually on or off. So I've set them up here. So I have one subject that is the active toggling, and then I have the light switch behavior subject that we had seen before. So what this is going to do is I'm going to create up this new observable sequence, observable stream, based on the act of toggling. So I'm going to say every time that I toggle, I want it to pass through these different operators. So I want to say, okay, I toggle, now give me the latest value of the light switch. Okay, is it on or off? It'll tell me on or off. And what I'm doing here is, well, I just care about, sorry about that. As I talked about before, with latest from will then give you an array of different values that have come up above it. So in this case, it says, give me the latest value of this toggle action, and then light switch. So toggle and light switch, but I only care about the second one. And then I'm going to map, and I'm going to say, whatever value that light switch is, I want it to be the opposite, so I switch it. And then I can listen and read what it says down here with my debug operator. So I can go ahead and say this light switch toggle. So everything that's going on here, this observable, I want to subscribe to that. And the output of this, I want to be pushed back onto the light switch. So again, this is your reducer function. I'm transforming this value, transforming the value of light switch based on the action of toggle. I can simplify emitting a value on the subject by just having this other function called toggle, in which all that's doing is emitting a value of null onto that subject. Because maybe for this case, I just want to know that I've taken the action of toggling, but it doesn't need to know any more than the action happened. So again, the output of this is every time that I say toggle toggle, I'm going to be getting this value that says true then false and true then false. Questions on that? Okay. So a subscription, we've written it by saying .subscribe. Again, nothing happens unless something is subscribed to it. So it's basically saying, I'm not going to do any work unless someone's listening. So as an example, here, I can say interval and give it a second. So I want to say I want to emit this thing every second, but no one is listening. There is no .subscribe against $$ anywhere. Therefore, it's not going to do any work. Down here, I say subscription equals $$ subscribe. Therefore, that subject or that interval will now start working. It will now start ticking. There's different signatures for .subscribe. I'm not going to get into it, but there can be cases where there could be errors that happen on the observable stream. So you might want to listen for those and handle things a little bit different. So there's some other variations, but we really don't have to get too much into that right now because we're low on time. And there's lots of different ways to unsubscribe. So again, if you subscribe, if you don't unsubscribe, you could basically be creating a memory leak. It's just something that kind of happens in the background, but maybe you forget about it. So we've shown examples of saying .unsubscribe. So when you know specifically you're done with a subscription, you want to go ahead and unsubscribe from it. So you can manually call it. There are different operators that will automatically unsubscribe for you. That was our take while example before. It would continue on doing this thing up until this value returns false or whatever. So anyway, there's some variations there. We talked about manually unsubscribe. So that's just where you say .unsubscribe. And automatic unsubscriptions. There's a lot of different examples here. I'll let you guys go and explore it on your own time. But again, there's certain operators like of and from and take while and take until that can automatically terminate an observable for you. For the most part, we aren't really caring about that because whenever we create a component, we want it to continue to live, continue to respond and do things up until the point that that component is removed from the DOM. So we won't really be using these things while we are building our app. There's ways to group subscriptions. So if you have a lot of different subscriptions, there's ways to simplify unsubscribing them in bulk. And then I also have a slide here at the end that is talking about errors. So errors can cascade through the observables, and there's ways to catch them and respond to them. And an example of that could be if you're doing AJAX requests. I have an example here where you have an observable that is based on a server request, and there could be errors that happen on the server side. You can respond to them. So again, I won't go into that because we don't have time, and it's a little bit outside of the scope of this. But just know that's all there. So that's a big overview of RxJS. Any questions about any of this before we get diving into some code? I think a lot of this won't really start clicking until you actually start typing your keys anyway, but that at least kind of gives you the lay of the land. Okay. So we are now done with the slides folder. So to give everyone an overview of kind of this folder structure, what's happening here, we have this lib folder. This lib folder has, actually, I can go in here. I try to put READMEs kind of everywhere throughout the repository for you guys to look at. And there are a lot of different utilities and things that I've built in, and I've tried to document them reasonably well. But anyway, we have this components folder. This contains all the styles that we're using for our DICE app, and then actual references to the finished version of each one of these. So if you click in here, you can see that DICE button.js, which ideally we'll be writing, the actual solution is covered in that folder, which I'll bring up and show you in a bit. But these are basically shortcuts, import shortcuts. But for the most part, the thing that you'll be using the most is libutil. And I have an overview of a lot of different things that we'll end up using. As an example, we have a function here for decode and encode. So what this is saying is, I want to write my dice in a format that says 2d6. And I want that to mean something other than just a string. So I have this function that will basically give you an array of objects that gives you a little bit more detail about what that means. So it's a little bit easier for you to actually use that information. And then there's an opposite. So I can take an array of objects and transform them back into a string. So anyway, there's a lot of different pieces into here. If you're interested in some of the DOM things, early on, Mega was asking about define. So this helps to explain that a little bit more. So there's lots of different pieces here. And because we're primarily using RxJS, this Rx folder is full of a lot of other custom operators and other things that I wrote for this, built on top of what RxJS already provides. And the demo that we had seen just runs these files, so our HTML file. And really, this is all pretty simple. but you probably haven't seen it before. So we say script type equals module. We had talked about that earlier using ES modules. I'm using a thing called ES module shim to basically give us the same capabilities and some things that are kind of coming up in over the next year or a couple of years. It's basically like a polyfill of sorts. But the only difference is, in order for that polyfill to work, you just say the import type is module-shim rather than just module. And we are using a thing called import maps in order to allow us to do things like import RxJS, and you just say RxJS, and the browser's like, where is RxJS? I don't know where that thing is. Import maps gives that ability to map it to where it actually is. And all those mappings are here under this web modules folder, and this gets created for you whenever you said npm install, which was part of that. So what it's doing is it's creating all of these different files for you automatically that the browser is able to read, and it's kind of doing the same sorts of things that Webpack would be doing for you, but the browser is doing it. So this import map.json file, as an example, is anytime that we say import from RxJS, what it's saying is I'm going to be importing, it's looking at this key value, and then it says, oh, here's where RxJS lives, and it's this file. And this file is a JavaScript module for that dependency. So anyway, that's an overview of kind of what's going on technically under the hood, but you don't really need to know those nitty-gritties. I just know some developers might be interested in how the heck is this thing running. So any questions about that before we actually get into the code? Okay, so if we go back in here, exercises is where we're going to be working off of. And I try to give an overview of these different exercises here. We have 7 different ones. We are definitely not going to get through all 7 of them. I'd be pretty happy if we just get through 2 of them, but we'll just go and go as far as we can. So we have 2 different folders for each exercise. One is your starting point, and then the other is your ending point. So for here, exercise 1, we can just go into start, and that's just this 01 dice button folder. And this tries to give you an overview of what all we're going to be building out here for this exercise. So we're going to be building the kind of lowest level component of our dice app, where we're going to be essentially writing button is dice button. Then we have our API here to help explain kind of what's going on and what's the inner expectations. And then I've also listed out dependencies. So if you're following along, then you're like, okay, what the heck is define or fromProperty? Click on that, and then that will take you to the proper documentation that is either internal to the workshop or external on the RxJS website's documentation. So that's just mainly to give you an overview if you decide to work on any exercises on your own. So I am let's see here. I'm going to quit this. Okay, I'm going to be working in our Visual Studio Code terminal. And get branch. So I'm currently on the master branch. I'm going to go ahead and create a new branch to work off of. So if we get stuck or whatever, it's easy for us to revert back out. So I'm going to say get checkout -b. And that means I'm going to be checking out from a new branch based on the current one. And I'm just going to call it workshop. So that should be good to go. I can just say get branch to double check, and then it says, yep, I'm here on a workshop. So if I'm going to go ahead and move this thing around a little bit so I can see what's happening here. I want to go ahead and start this. So I'm going to say npm run start. That opens up there. And from here, I'm going to show you what the ending point of this first exercise is. So I'm going to click here onto dice button solution. And what we're going to be doing is just showcasing one dice of each of our 6 different dice type. Clicking on it isn't going to do anything because that's going to happen in a later exercise. But if we open this up and look at it, what we're seeing here is we have directly under body, we have an app called dice root, and that is just our overall container for everything. And underneath there are 6 different buttons, and this is in the built-in custom element variant in which we're saying is something. So we say a button is this custom element, and then we have these different values here. Now the cool thing is, because it's web components and how we will be writing this, we can also transform any of these things by using attributes. So for here, this is currently a D4. I'm going to change this to like a D8. So that just changed live right there. I can change this label. A label is just this one value, and I want to say maybe I roll a 6. And then just it live updates that right there. Let's say I don't want a medium-sized button, I want a small one. There's a small dice. And maybe the theme is, instead of solid, it's ghost. So there's some of these variants I will end up using. But again, it's pretty fun to be able to just go in here in the markup and just modify it live. So I'm going to bring that down. Give us a little bit more space to work with. And so if we open up dice root, this is already defined for us. So let's give us more space here. So what we're doing here is we're going to create a new component called dice root. This, again, if we look in the HTML file, this is all that we're doing. We're just saying dice root, we're defining our application. That's where it lives. And then we are, the main script that we're pulling in is index.js. That is this file, and the first import statement is just basically going to be bringing in all of the CSS files that we need. That's also handled through this module system and just the browser natively. And then we're going to be pulling in 2 files. One is dice root, and then one is dice button. So again, dice root is already created for you here at the start of this first exercise. And what this is doing is just saying that whenever dice root gets plopped into the DOM, I want to immediately render something. And what I'm going to be rendering is 6 different buttons. So I have a constant in this const file that is just an array of these different types here. So it's just, 4, 6, 8, 10, 12, 20. So I'm just looping through those, and then I'm going to put down this button for each time. And the only variant is going to be, I'm going to be changing the number of this face attribute. And that's why we get, these 6 different kinds here. So again, I could go in here and say small and press save, and then that should live refresh. That did not. Okay, well, maybe, oh yeah, we're looking at the solution here. So if I back out and go back in here, so yeah, I was looking at the solution one, I was changing the wrong file. So if we go back in here, we're gonna actually be writing. So, so for here, make sure that you're in the right file. It's blank. It's blank, but if we look into inspector, we can see dice root, and we can see that the buttons are kind of there, but they're actually not rendering, and that's because, well, our dice button folder is empty. So we actually need to start writing so something actually gets happening here. So to save some time, we can go ahead and just grab this first line from over here. So we want to go ahead and define dice button. And the second argument here is something that we'll only use for this one exercise. And this is where we're going to say it's basically that is button type. Then we're going to pass it the callback. We say element, and then write it down. So now, if we say console log, and then just pass it in something, if I save it here, this refreshes, and now I can see that here are the different button elements that get rendered. So the define worked for us. Sweet. Let's see here. We want to go ahead and render something. So let's type a function called render, and we'll end up providing we have to pass in something to it. So I'm just going to call it props because that kind of follows some of our a lot of conventions that are out there. But for right now, we are going to ultimately return HTML. And so we're using this HTML import from up above. And let's go ahead and just write some dummy stuff. So here's, I don't know, dummy stuff. We can go ahead and say render and this will kind of get us somewhere a little bit more, I guess. Let's see what that looks like. Ooh, error. Oh, it's already been defined. Okay, here we go. So let's say I say render component. Let's save that. It's kind of hard to see there, but it says dummy stuff there. Do you guys see that? So here we've actually been able to do something there. So let's actually get this markup to actually look kind of like what the app is expecting, what the CSS is expecting. So we can say SVG class equals icon, and then use xlink colon href, and so this is going to be a way for us just to get the background image on there, so the actual shape. So if we, this icon that we're referencing here, we can just define it up here. So icon is going to be actually located here in our lib folder. So if you saw dice.svg, it's there. And in order to do these SVG symbols, has anyone seen SVG symbols before? So I'll quickly show you what that looks like. So it's essentially this file is what we're pulling in. So it's an SVG file. Normally, when you deal with SVG, you think of like one graphic image per file. A symbol file means that you can have any number of them. And so you just say symbol, and then you give it an ID. And what we're doing is we want our markup to reference this ID. And that's how it knows which image to put where. So that's what we're doing here. So when we say use this xlink href, that is that ID that we're trying to get to. So we have to say where it is, and then we have to give it some value, and we want it to be dynamic. So we're going to say type, and so this type is going to match that ID format, which is going to be the letter D plus a number. That number we're just calling faces because this dice, they say there's 6 faces to a D6. So that's what we're saying here. So we can start off and just say const faces equals 6. So what we're doing is we're setting up where we take the 6, we say it's going to be a D6, and then we're just putting it up here within the string. You could format it however you want to, but that's what I'm doing here. So let's just see what this looks like. Hey, there we go. So now we have a bunch of squares. That's pretty cool. Did you guys see it? You saw the squares? Yeah. So if you can change this to, like, let's say a D8, then save and refresh, and now it's the diamonds. So that's pretty cool. So let's also add a label to this because we'll want to see the value of it. So you can do that by adding another div, and this div will have a class of label. And then the inner contents of it, we can also just call it label. And we can pull up here and say const label equals 1 and save that. And let's see. So yeah, there we go. So now it renders that there in the button. Any questions about that so far? Okay. So let's now make this part of props. So far, we just kind of put it in here. But let's do something where I want to pass that value in more dynamically. So I can say faces 12 and label 2. And then in here, I can just say const faces label equals props. So if you're not familiar, this syntax is relatively new, but essentially allows you to pull out this particular key from this object and destructure it. So it's the same thing as just saying const faces equals props.faces. It's just a shorthand. So if we go ahead and save this, now we have a bunch of D12s that was passed in from this higher level. of the rather than within the function itself. Questions about that so far? So far we haven't used RxJS. This has just kind of been setting up how it renders. So let's kind of make that a little bit more dynamic. So one of the things that is within our utils is a thing called fromProperty. So let's go ahead and import that. fromProperty, and this is from /lib/util/rxjs. So fromProperty is going to set up a lot of stuff. It's actually the most complex piece of the utilities function, utilities folder that I set up. And I'll get into those as we get this going. So what I want to do is here we have faces and label be something that we've kind of written here, hardly defined, like we've written it here in this file, but we want to make it dynamic. We want the DOM to control that value. We don't want this JavaScript file to control that value. So we're going to be using RxJS to listen to those changes to the DOM and automatically put them onto an observable for us, so then we can listen for them and respond to it. So we are going to say, we'll start with faces. So const faces $, because it's going to be an observable that we're creating, equals fromProperty. And again, this is a custom thing that I built, but the signature is going to be, you're going to pass it the element that you're going to want to put on here, and then the name of the property itself. So we're going to say faces as a string, and we're going to pass it some arguments as the third and final thing. And there's lots of different ways to write this up, lots of different options that I wrote. But the first thing is this type. So I want to say it is a number. And so what this is going to say is I want to take that DOM attribute, which is a string, but when it comes into here working with it, I want it to be a number. So this basically allows us to dynamically decode that value for us. So there could be other types that could put in there. And I'm going to say there's going to be a default value. So let's say that the attribute wasn't set in the DOM. Then this gives us kind of a value to start off with. So that's all written for us. And now if we go back here in dice root, again, what I'm trying to do here is transform this faces attribute, which ends up becoming a string because it gets rendered to the DOM. And I want to pick it back up here. So let's just look and see what this thing is doing. So if I say faces.pipe, what I want to do is inspect what's going on underneath within this. So I'm going to pull in debug, because again, I showed you that earlier. So now I have debug and fromProperty is both coming from our internal Rx utils. And I'm going to put that in here. So debug. And for right now, I'm just not going to put in any arguments, but I'll show you what this looks like. And then later on, I can put in arguments. So here I'm going to say .subscribe. So again, the output of this is a subscription. If I'm not going to do anything with this subscription, I don't have to say const subscription equals, because it just exists in memory. But anyway, this allows us to now essentially initiate this thing because something is subscribed to it. And then we're going to inspect it. So what we're going to be doing here is just really looking at console log. Again, this is not yet tied up to a rendering function. So anything that we're doing isn't necessarily going to be affecting the rendering. So if I save this, I go back in here and say console log. Let's see this a little bit more. And okay, let's get rid of this console log statement to clean it up a little bit. So what we've done here, we see 4, 6, 8, 10, 12, 20. That means we have 6 different buttons. Each button, this has been rendered uniquely for each one of those 6. So they each, there's like 6 different observables of this fromProperty that is existing in memory. And if we go in and change some things, so if I go in here, and let's say for this one, I change faces value to 8. Now if I go back in here, now you see 8 at the bottom there. So it saw that change, and then it went ahead and printed it because I'm listening for it because of the subscribe. So again, I could clear that just so you can see that I'm not fibbing, and I'm going to make this a 20, and now you see 20 there. Any questions about that so far?
Yeah, it looks like you're creating a const called faces $, and as a third attribute, you're passing an object. Oh, okay, never mind.
Yeah.
I was just, okay.
Yeah, it was just clipped. Sorry about that. Okay, so now, and then if, let's say we want, rather than just the output of this, I want to put in something here in console log so I can kind of see what's happening a little bit better, because maybe I have lots of debug statements everywhere. I can just pass in this custom string, and then now you see faces there. So that kind of helps you kind of identify what you're looking at. So that works. So now let's go ahead and make it where we need to take that value from the DOM and we need to re-render based on it. So we are going to use another thing to, well, okay, let's start off without that. Let's say I'm going to say faces dot pipe, and then I'm going to say render component, and I'm going to switch some things around. Up here, when I say render, I'm not going to use that anymore. I'm going to use something called render component. The difference is that original render is just like what the rendering library gives you to be able to do whatever. Render component is a custom thing that I built that is a RxJS operator to render something. So we'll see how this looks. So if I rewrite this to say render down here, just so the names don't conflict. So now what I'm doing is every time that this faces value changes, I want to re-render. So I'm going to be passing through this custom function, and it takes in 2 different arguments. The first one is where it's going to go, and then the other one is what is it going to render. So I'm just passing in a reference to this object here. Now, this thing, so if I, so this render function is actually expecting an object, but the output of faces is just a number. So how do we get it to match? Well, one quick way is just to do a map function. So if we go back up here and let's say import map from RxJS operators. That gives us RxJS's map. And so what we want to do is make sure that all these operators is comma delimited from one another. So that's why I added the comma right there. So I'm going to take faces, which is a number. I'm going to transform it into an object. So then it's in the format that this render function down here expects. So I'm going to call it faces. And then I'm going to return an object with the key of faces with the value of faces there. This is just shorthand for saying faces, or I guess if you really want to be longhand, I can say function faces equals return faces equals faces. That's a long form of what this is doing here. Does that make sense? I think I saw someone on the chat. Oh, no. Okay. So I'm going to take that away and bring this back. So now, we're not going to need this anymore, but I can go ahead and say .subscribe up here. So I have one subscription based on this. So now theoretically, this is all set up, so we'll cross our fingers and see what happens. So now we have all of these rendered. So I should be able to take this 4 and say 6, and there we go. We're using RxJS to listen for DOM changes, and we are then rendering using our rendering engine. Any questions about that? Does that make sense? So we need to do this one more time. So we have faces is one attribute, but label is another one, and we haven't hooked that one up. So we can go ahead and grab that one. I just copied and pasted it. The difference is maybe the default value is an empty string, and the type is actually a string rather than a number. And we call label, and call this label. So, so that should basically do the same thing that we had, except for now we can be listening to another property altogether. And so now we have two different things we want working together. So how do we combine them into a single object that this rendering engine has? So we can end up using a static operator called combine latest. And that's from the RxJS import. So we can end up saying combine latest. I want the latest value of faces $, and label $. And now the output of that is going to be an array of both of those values. So let's go ahead and just pipe and debug that just to see what's going on underneath the hood. So I'm going to set up a new subscription for this thing just so we can see what's going on. So if I save that, so here we can see that we have the value of 4 and the string value of 1. That 1 again is this label equals 1, and it's an array. The array is what comes out of the combine latest. So let's say that one of these things change. I'm going to go ahead and clear this console, come back over here. Now, if this faces changes to a value of, let's say, 8, I go back here, now it says 8.1 because it picked up the change and it says, okay, here you go. So we're going to use this and combine it down here. So let's say I'm going to white this out. So this value is not just one value. Well, it's an array of multiple values. So let's make that into an array. And this is in the same order as what happens up here. So faces is the first observable that you set up. So therefore, it's the first value within that array. And then label is the next one. So again, I'm not putting in a $sign in here because this is no longer an observable. This is the value that's in the observable. So now I'm going to say faces and label. Now I've mapped that. So now I have those two different values. I've mapped them to array. Then I've mapped that array to an object. And that object is your props that goes into your rendering function, which then comes out here. So I save that. And now we have this. So if I go in here, I can change the label. And I can change the faces. And all this works. It's all hooked up. Any questions on that? Okay. I'm going to show you another trick here, and then we'll take a break here in about 5 minutes. So this combined latest and this mapping is something that kind of happens a lot, especially when you're building out components. So I have a simpler thing that you can use. So it says combine latest object, and that's from within our same internal utilities. And so what this is going to do is I can say combine latest object, and I'm going to write the shape of the object right here that I expect the output to be. So what I want is I want an object with a key called faces, but I'm going to be, instead of actually passing in the value here, I'm going to be passing in the observable that maps to it. So I'm going to say faces $. And likewise, I'm going to say label $. So what this is going to do is essentially make it where we don't have to write combine latest plus a map statement. It allows us to immediately go from an observable or any number of observables to the object down below. Does that make sense? So I can go ahead and remove this. This will be our top level. So I'm going to say .pipe . And then if I save this, then this should behave just like what we had seen before. So there's a 2, and then there's a value that's changed. So we have that. And then if we want to go ahead and set up our unsubscriptions, so like at this point, this component is basically where it should be. But I have no setup for when the thing is removed, I'm not unsubscribing. So therefore, I'm kind of potentially creating a memory leak. So I want to go ahead and just give this thing a name. So I'm going to say render $= equals. And I'm going to remove well, yeah, let's see here. So yeah, I have this, I can split this up, this will be fine. So I can say const sub, short for subscription, equals render $.subscribe. I could combine this any way that I wanted to, but this just helps you to see the pieces a little bit more. And then at the bottom here, I can say return a function that whenever it's called, I want to unsubscribe. So again, this is just a nice way of making sure that we don't have memory leaks. You unsubscribe things whenever it leaves the DOM. Again, if I save this, then it still works. Cool. I think that's all the time that we have for this one exercise. Let's take a 10-minute break. We'll come back here at 3:30, and then we'll work on one more exercise, and then just probably that'll be as far as we'll be able to go. So thanks, and we'll be back shortly. Okay, thanks everyone. We're gonna go ahead and get going. And again, we only have time for one more exercise. And I encourage you to continue on or reach out to me as needed. So one neat trick that I wanted to show you guys, the fromProperty that was created here, it's more useful than just changing attributes, but it was specifically about also changing in a little bit more of an imperative way. So I can show you a trick just to kind of prove what I'm trying to show here. I'm going to say set timeout. And so what I want to say is, let's say after 5 seconds, I want to magically transform all of these buttons, or all of these dice into a different thing. So if I go back here, not to the solution, but this one. Not the solution, but this one. So they're all of this type. I'm going to say element dot faces equals, let's say, an 8. So what I'm going to say is all 6 of these buttons, I'm going to transform this value to this number. So I'm going to change this property value. If I save this, this refreshes, and hopefully, if my magic is right, boom, there you go. So again, when I say fromProperty up here, there's a lot of internal weird mechanisms that I put in place that says that I can change this property on this element to anything using this mechanism, or changing it through an attribute, or actually changing it by updating, by emitting a new value on this subject. So I could also do it where I say set timeout. Let's change this. So in 2 seconds, I'm going to use this way to transform it. And then I'm going to say set attribute faces. In 4 seconds, I'm going to change it using attributes. And then in another 2 seconds after that, I'm going to change it using streams. So let's see whether that works. So there you go. So there's lots of different ways to be able to get information into RxJS and do what you need to do. And that fromProperty just kind of sets up all of those things for you. So again, that's why it's pretty complex. But it can also be pretty useful as a tool to allow you to interop with different technologies or different techniques. So I think that's going to be as far as we're going to go on exercise 1. And we're going to skip to exercise 5. And exercise 5, if we go down here, is going to be our dice input. So it's going to be similar in nature to what we had just done, where we rendered 6 different dice, but this is going to be our mechanism for inputting what our dice configuration is. And again, if we go back in here, just as a reference, we are basically building up this piece. And what I really wanted for the second exercise is to work on this, where you can click on it and then it'll randomly roll a new number. But again, we just don't have time to go into that. So we'll focus on this piece. And so this will, show how you can set up individual components that kind of work independently, and they control their own internal number. So in this case, I'm clicking in one direction to get this to a 0. I want 0 of this dice type. Now I have 1 of this dice type, and etc. So you can kind of use that pattern and kind of extrapolate it to a lot of other things that you're doing anyway. So any questions on that before we get going? Okay. So like before, we're starting off with a blank screen. So if I open this up, and so again, we're looking at exercise 5, dice input folder. I mean, look here in index.js, and we're going to be pulling in dice button that we just had finished before, plus dice picker, which is completed for you. But then we're going to be writing just dice input.js. That's going to be what we're going to be focusing on. So like before, dice picker, at least for this first exercise, looks very similar to what dice root did on our previous one, where we're just looping through. And in this case, we're going to have a component called dice input, where the input value is the faces. You could actually start off with an initial value if you wanted to. So maybe you want to start off with all of them having the value of 3. Again, it doesn't show up here because we haven't finished that, but we can still go in here and kind of see what's happened there. I've put in that value. So anyway, that's going to be our foundation for this exercise. So we can go ahead and go into dice input. And so like before, we're going to import a number of things. So we have define and HTML and render component that will kind of be with us for all these exercises. And you can copy and paste that over if you wanted to. So we're going to say define and dice input. And again, because this is not a built-in component, we don't have that second string argument. So we're just going to immediately go into a function where we say element. And now we are initializing our dice input component. And we can go ahead and also set up our rendering function. So render props, this will look familiar. And we're going to have a few different things that we're going to want in here. So we have faces, type, value. That comes out from props. And then we're going to return some HTML. And that's in those tick marks. And again, if you don't want to type out some of this, you can copy and paste it from the other file. And actually, just to kind of, well, yeah, I'll just type it out, that's fine. So we have class equals label, type div. Well, I'm just going to do it for right now because we're low on time. So I'm just going to grab this, if you guys don't mind me cheating a little bit. And I encourage you guys to cheat too. Because again, you're low on time, so you cut corners where you can. And this will be a good place to cut corners. So what we're going to do here is this top label is this thing that says like D6 up there. Then we have two different buttons. This second button, or the first button is this thing where it's a shape, and then there's a ghost equivalent to it. So we're essentially saying that if there is a value, so essentially if the value is 0, then it's going to be a ghost theme. That's this kind of outlining thing. And otherwise, if the value is at least 1, then it's going to be solid. So that kind of allows us to kind of see that value a little bit more. And then down below here, our button that does the removal, that will just print out the current value. And so that's where we see that it's a D6 times 1. Essentially, it's a 1D6 or a 2D8. That's what that's trying to do here. So we have our markup that is set up. And what we want to do is essentially have a number that responds to click events that happen on either one of these buttons, and increment and decrement based on that. So if we go up here, we can set up some simple things like what we had before. So we have const faces equals fromProperty. So element faces. So again, this is similar to what we had before. Default value 6, and it's a number type. And this next one will also be a number. This is our initial value. Our initial value we're going to say is 0. And if we go up here, we'll want to import that property. And oh yeah, this should be value. So down below here, we need to set up our rendering. So we talked about combine latest. So with this, we're going to pass it an object where we say faces is faces, and type is type $. Oh, okay, I haven't defined that one up yet. No, this is value. And so here we want type, and we haven't defined that yet. So we're going to create a new observable that's going to be based on another observable over here. And then, so once we have these things, then basically the rendering function is going to have all 3 pieces that it needs to get going. So with this, we're going to say const type. This is going to be derived from faces $. So type equals faces $. We're going to say pipe. And what we want to do is map it. So we're going to say anytime that faces changes, I want type to be similar but a little bit different. So I'm going to say faces is a value that comes out of faces $. And I'm just going to make it into the same thing that we had seen before, which is D and then the number. So just that, is what's given us our D6 there. So we could have done this by just also just saying D faces. That would have been the same thing. But it's a different way of just allowing RxJS to kind of allow you to do derived things from it. So I need to import the map. And then we could do that. So now we have our pieces lined up. So if we go ahead and save that, I believe something might work. Oh, we haven't rendered anything. So we have this combined latest, but we still need to do something with it. And so that's where we'll just go back in and do our pipe, use our render component operator, pass it in the element and passing it in the render function. And then at the end, we can just say dot subscribe, and that'll be fine. So there we go. Now it's all rendered. Now we can change some things because we have value up here. So let's say I go in here to this input, and you can see this initial value is 0, because that's what we set up here. Default value is 0. So I'm gonna change this to a value of like 4, and now this just automatically updates for us. So our goal is to update this value $ stream, which means it will update all these other pieces for us automatically, but based on those 2 different button clicks. So there's some different ways that you could handle it. There are ways of being able to, so if you're using React, if you want to put on a handler on something or a click handler, you can say on click equals, and then you pass it a function. You can do something like that with lighterhtml, where you can say on click, but it's lowercase, and then you can pass it a function. I'm going to show you a different way of doing it. And what I don't like about putting handlers directly on elements is it makes it where there's a much stronger connection between your logic and your markup, and it makes it a little bit more difficult to test. So what would be nicer is the button can just fire off its events, and those events bubble up, and we can just dynamically listen for those events and capture them. So in that way, we're just creating a stronger separation of those concerns. So there's another thing that we're going to pull in that's also custom. And this is called fromEventSelector. So what this is going to say, we're going to say const increment $. So we're going to create a new observable using this custom one from EventSelector. We're going to pass it the element as the first argument. The second argument is going to be essentially the CSS selector to find the thing that we're interested in. So for here, we want to target this, this button and not this button. So we have added this increment button class to it. So we're actually using that to kind of target it. So this is going to say, I'm interested in anything with a class of increment button that's within the scope of this element. And then I'm specifically interested in any of the click events that happen on it. So now when I pipe, and I'm going to go ahead and come down here and say increment.subscribe, just so you can kind of see what's happening before we get everything hooked up. So I'm going to pull in debug from here. And so what I'm going to be looking at is all the click events that happen on those elements. So if this refreshes, I go to console, I click here, and then those are those events. So if I put focus, that's what's happening. So I'm now listening, and I know which elements are emitting what events, and now I want to transform this thing into some sort of a change. So what I want to do is I want to change the value of value. So I'm going to use, I first need to get the current value, and I want to say I want to increment it. So again, this is pretty similar to what we've done before, or the countdown example. So we're going to pull in another operator called with latest from, which again, you've seen before. And latest from. And we're going to get the latest value of the value stream. And then we're going to map that into another thing. So again, the output of with latest from is an array. The first value will be our event that you had just seen here with this debug statement. And then the other one is going to be value. So we're going to take this, and we just want to take value plus 1. So essentially we're saying we don't care what the contents of that event is. We just want to know that it happened. So now if we go ahead and debug from here, not much is going to happen, but something different will happen. So if we'll just save this, you can see here that all that this is doing is saying it's taking the value of 0 and adding 1, but we actually haven't changed the value stream yet. But you can at least see that it's at least seeing it. So we can change it by just saying, well, essentially, well, actually right down here, increment.subscribe. We just pass it in value here. So what this is going to say is the output of this is going to go directly up to here, which will change everything. So we save this. And now that's set up for you. And again, these are all running independently of one another. So again, that's showing we've selected an element, we've transformed it, we've reinterpreted it and said, well, we mean that we want to increment this value, and we say, where does that value live? It lives up here. And then it propagates everywhere else. Yep.
So could you get rid of with latest from and then change the next line to, instead of value plus 1, it would be like value $.get latest or whatever?
Yeah, so like if, if you wanted to do something different with it, you could say map like this. And so what this is again saying is I don't care what the event is, but I could say value $.value, or I could say .get value parentheses as a method call, and then say +1, and of course return that. Or I guess you could just have that together on one line if you wanted to. And this should theoretically be the same thing. Yeah.
Okay, thanks.
So yeah, but the downside of doing this is you're imperatively asking for it rather than just using the streams to get it. So I guess just to be respectful of time, I think maybe that's where we'll end up ending, unless people want to see how to hook up decrement, or whether anyone wants more time on this. So I'll leave it open for questions or whatever else that you guys want from this. Is there any other sort of magic that hasn't been said in your head yet that you're like, I want to know this thing? Yeah.
Some applications that we use, or that we've written, use React and Redux.
Mm-hmm.
I'm wondering how this fits in,
Mm-hmm.
and where, yeah, if we can replace any of sort of the infrastructure that we've been doing, or what.
Yeah. So Redux is basically one giant object, and then you're using reducers to transform little pieces of it. I've wrestled with that idea for a long time, and there's a variant of that we actually use within enterprise student systems, where we're using RxJS to do it all. So rather than having one mega object that you're trying to figure out how to get into certain pieces and transform it, then you have this one big object that then is shifted around everywhere, and then you have to use selectors to drill it down. My argument is each one of those pieces, the pieces of that giant object, could be an observable. It could be a behavior subject. And so that way you can be a lot more targeted in the individual pieces that you want to listen to and get updates from. So essentially, if you just have a bunch of behavior subjects, that could basically be everything that you need. And then you use these observables to do derived observables from them. You can pass them around. You can use them to essentially build up props like what we've shown here. And that's essentially your idea of your selector. And kind of like this, you're using events or actions to change values within behavior subjects. So that just kind of propagates everywhere. If you want a little bit more structure than that, there is a project called Conduit that is something that I wrote a number of years ago that we use. So if you go to github.com/Indiana University/conduit, this is some examples and of basically how to do the same thing. So it uses, it's a set of utilities for RxJS and some utilities for connecting RxJS to React. And there's a lot of patterns that are set up in there. So, we can talk about it later if you're interested. But that's a direction to go.
Thank you.
Any other questions? Okay, so next steps from here. I will be posting the recording in a place that you guys can have access to, and likely within the next week or two, if it'll all be wrapped up into our main repo over here. So then you guys can kind of like review it and the video and share it around as you might want to. Feel free to reach out to me for any questions. I've been using RxJS for a number of years, so I've been quite into the weeds of it. And we'll just kind of go from there. Please reach out and enjoy.